AI rising for glaucoma.
With the development of new technologies, artificial intelligence has been one of the most influential information technology revolutions in the current world. Artificial intelligence, or AI, is an area of computer science that emphasizes the creation of intelligent machines that works and reacts like humans. It deals with development algorithm that seeks to simulate human brain and also mimic cognitive functions that humans associate with the human mind, such as learning and problem solving. The application of artificial intelligence in ophthalmology mainly concentrates on the diseases with a high incidence, such as diabetic retinopathy, age-related macular degeneration, glaucoma, retinopathy of prematurity. Artificial intelligence involves mainly 1. Machine learning, that are algorithms with the ability to learn without being explicitly programmed. 2. Deep learning, in which artificial neural networks adapt and learn from vast amounts of data. Do we need artificial intelligence in glaucoma? Glaucoma, the silent killer of eyes, is the second most common cause of blindness in the world. Its prevalence has reached over 60 million by 2010 and over 80 million by year 2020. It is so common yet so easily overlooked. 50% of individuals in developed countries and 90% in developing countries are unaware of having glaucoma. Early detection can delay the progression of glaucoma. Hence, the time has reached to emphasize on glaucoma screening. Glaucoma detection is mainly using 90D lens for fundus examination, applanation tonometry for intraocular pressure measurement, gonioscopy to visualize angle structures, Humphrey field analyzer for analyzing visual fields, optical coherence tomography for seeing optic nerve head changes, and pachymetry for measuring central corneal thickness. But there are limitations to screening, such as disparity between ophthalmologist-patient ratio and also the availability of the specialty services. The large amount of data acquired from patients make it nearly impossible for ophthalmologists to screen them with equal efficacy and consistency. The possibilities of AI are exciting, especially the ability to speed up and streamline diagnosis and reduce the risk of errors. The algorithms provided by AI may be able to pick up on patterns too complex for humans to identify and determine which patients are truly at risk. AI does this by interpretation of fundus photo, fields, OCT, structure and function correlation. Consider this picture. An ophthalmologist can look at it and immediately know that it is a glaucomatous cup. To the AI, the image appears as pixels in a 3D manner with length, breadth and width. It interprets these pixels to form an image. ONH abnormalities can be identified using AI through machine learning and convolutional neural network evaluation strategy, a type of deep learning. How does a CNN know what to look for and if its prediction is accurate? This is done using large amount of training data. When the CNN starts, as the filter values are randomized, the initial predictions make little sense. Each time CNN makes a prediction against the trained data, it uses the error function to compare how close its prediction is to the actual image. Based on this error or loss function, the CNN updates its filter values and starts the process again. Therefore, when an input image of a fundus photo is fed into a trained CNN model, it is finally giving an output whether it is glaucomatous or normal. It is possible to estimate visual field test results such as visual field index and mean deviation from raw optical coherence tomography data of healthy and glaucomatous eyes using the archetype analysis method as developed by Els et al. It is exciting what AI can do what the human brain cannot. Where are we now? There are currently large number of studies published regarding AI and ophthalmology. The fundus image is taken by the fundus camera, fed into the AI, and it gives the result. There are clinical and technical challenges in building and deploying deep learning techniques from bench to bedside, such as lack of large sample size and generalizability to apply to different races. A single program cannot hold good for different types of make and model of machines, and ethical challenges. The future of AI in glaucoma dreams of achieving goals like including factors such as clinical data, genomic data, lifestyle behaviors, risk factors, medical history to predict risk of developing glaucoma, best management protocols, prognosis, and surgical success. As quoted by Benjamin Bell, AI will not replace doctors but instead will augment them. Thank you.